Hello everybody, welcome back to Advent of Code 2023 in 2024. I will be trying to solve problem number 18 or day 18 today. And I will be honest here because I don't have much experience with polygon or like geometric algorithms, so I had to search and try to understand how things are done there. So I have some idea how this will be implemented, but I haven't tried it yet. Hopefully it will work, but we'll see. So the problem of today is that you are given a list of edges of a polygon with some colors, and you basically go in that specific direction that they give you, and you go for a given number of steps, and this whole thing then results in a closed polygon that begins where it ends where it started. So it's a closed polygon, and your task is to calculate the area of that polygon, the number of points it consists of, and this could be done in a very general way, where you would just find which points are inside and which are outside, and then sum them up, which would work for this basic part of the problem. But the more advanced one, the second part of this puzzle, requires you to actually calculate this for a very, very large area. So that wouldn't work and would be very inefficient. So the better way to do it is to use some geometrical algorithms, and those I searched for, and I have them here. For the first part, to calculate the actual area enclosed by given points, given some edges, you can use the shoelace formula, which allows you to take a list of points and then use that to calculate the area of that polygon. Pretty simple, nothing too special there. But unfortunately, it's not enough for this problem, because in this case, we are given the points themselves, but because we are working with a 2D grid, basically the area that we would calculate is not the area or the actual area, the number of points, like the number of coordinates that are inside, but we would just get the inner part of it. So basically it would calculate the area from the middle of that point to the end, and like it would not include the whole thing. It would not include the whole point, but just like half of it. It's kind of weird to think about it, but it's the case, and so we need more to actually calculate it properly. And to do it, we can take another formula, which is called or theorem, which is called Pick's theorem, which tells you that the area of a given polygon is equal to the sum of its interior, the number of integer points inside of the polygon, which are the ones that are directly on the grid. So those are the points, and then plus the number of boundary points divided by 2, which is the number of points that are directly on the edges of the polygon, minus 1. So if you take this formula and plug into it the area that you calculate from this shoelace formula, you can then, based on that, because we know the number of boundary points, which are basically just sum of like the number of points that are on the edges, so that is quite easy to calculate. We can, using these two, hopefully, calculate the number of the points which are inside, and then then the output of the problem of the puzzle should be the number of boundary points plus the number of inner points that we calculate. It's a complicated one, but it technically should be very simple to implement, because it's just math and it's just calculating two different formulas together. So we'll see how that works. So let's get started here, and I will, what I will do is I will copy the input, and now let's try to do this thing. So input, read all lines. So we need to calculate the coordinates of the points that are there. So we can say that the point that we start in is 0, 0, and then we calculate from there. So origin be new point, not this point, but our custom one, and then I will have current position, which will be equal to origin, and then for each line and input we will parse it. So line split by space, I think that's it can be split by space, right? Yeah, so it basically split by space, we will get 3 parts. So we'll get parts. Now the first direction is part 0, exactly. The distance is part 1, exactly, and we don't care about the color for now. So now we switch direction, which means we'll go. The directions are right, down, left, up. So it's gonna be right. So we'll have a list of points. And what we also need is, or actually we could start without the origin because we will add it with the last edge. But what we'll also need is total boundary points, which will be initialized to 0. Let's do it all long for now. So let's make a point new position, and now we will, let's just delete this. We will do right, and the new position will be the current position plus distance, and so on. So now for left we'll do very similar thing. For up we will do similar thing. For down we'll do similar thing, and I want to do it rather than up will be minus and down we will plus. It's like it matches the visualization that down is plus in the y direction. But otherwise this is good. So now we can add new position to that list. We can increase the boundary points. Yes, that's basically it. Like takes the diff on both sides, and it's gonna be always 1 will be 0. So we are moving only in y or x direction. So it's gonna be the diff will be the number of boundary points, and the new position. Okay, with operation exception. So this is just to make sure it doesn't complain. Well, basically we can do origin, or I mean current position. And now finally we update the current position and we go forward with that. So we read in the whole polygon, and now we have the list. So we have all the endpoints, and we want to calculate the area. So calculate area using shoelace formula, and maybe Copilot will be helpful here. So yeah, this is not that readable. So I think I will go with for points area will be 0. And the shortest formula is basically you sum up the number let's see which one was the one that it seemed easiest to see. Basically you take all the all the points and you multiply the y coordinate by the previous and next x coordinate. So not sure if this is the correct one. All right. This is a different approach. I'm not sure if this one is correct or not. X and okay, so there is this one, and that seems to be the same thing. So it takes the next one minus previous one, and that's probably the one that's using here. Yeah. And we need to make sure that if we are at the end, we will go back to the 0 point instead. So next point and current point. Right. So this should be okay. And this should give us the area, and now the actual area should be half of this in absolute value, because it could be negative if we were counting like in reverse. So this should be all we need. And now, and that is the wrong area kind of. This is the one that does not give us the actual value, because we are counting half of the boundary points only. So now use Big's theorem to calculate the number of points inside. Yes. So the points inside, and this probably could be the one that we want here. So it should be area. So we need to get the I from here. So it's A minus B divided by 2 plus 1. Yeah, so if you change this equation to be to have I on one side and the rest on the other side, you get this equation here. So this should hopefully be the number of points inside. And I'm not sure if there will be some kind of plus 1 minus 1 issue. So I will have to probably output what I have. But it should not take too much to fix it. And finally, the total number of points should be boundary point total boundary points plus points inside. So that's the actual real area of that polygon. So let's try to run this against the sample input. So 24. So this is a bit more than I would expect. So 24. Right, wait, what? Total boundary points area. 42. Yeah, there's something wrong with my calculation here. So let's see. Okay, let's see what the points contain, just to verify if I made some basic mistake there. So points should be like this. So it's 0, 6, 6, 5. How do the points seem reasonable to me? That seems fine. So now the area is 84. Which is a bit too high, I think. So what is wrong there? xi times y plus minus next point, current point. That makes sense. So this should be the area correctly. Okay, so it's half 42. If 42 total boundary points is points inside is 24. Let's see, 24. 1, 2, 3, 4, 5, 6, 7, 8. 25. Okay. There's something missing here. So total boundary points. I'm probably just, I have this number wrong, I guess. So if I start with 1 there, (42, 40, 24). Oh, right. I can see the number of boundary points there. So let's see. Total number of boundary points should be 38. So that's okay. So that number is fine. Okay. So that was okay before, but total points, and I'm not summing them correctly. I can see that now because it was showing me not the sum, but it's 62, and that makes much more sense now, of course. So I guess the area and points were okay. Before I just had definitely wrong output. I didn't realize that it was such a high number immediately. So okay, throw it away. That was weird. And now that seems to be okay. So let's try to test it with the big input as well. So now the number is quite larger, but hopefully correct. And it is. All right, so that's the first part of the problem. And now let's go to part 2. So in the second part, we find out that the problem description is actually completely different because the distances and directions are encoded in hexadecimal codes. So I will take my original input from, actually I will take the sample input first so we can verify it. I will take my current code. And now what I will do is I will take, I will check how the conversion is done. So the first 5 digits encode the distance and the last is the direction. So we'll take v parts 2. We don't care about the others. And now the direction is last. So this is the last. This is direction. And the distance will be basically this. So the substring minus 1. But we will need it in we will need a convert to int 64 maybe from the string, and it will be in, no, that's not the one that I wanted, I guess. Also we get to int 32, okay. But no, that's not it. From base, yeah, right here. So from base 16. So this should give us the distance and this should give us the direction. So now direction will be right, down, left, up. Right, down, left, up. And it's going to be minus 0. So hopefully we could be getting the right values now. Even though I deleted new position, current position. I'm not sure how high the numbers will be. So maybe we'll need to make a special later version with longs, but we'll see. So let's run this. And I'm running the old version, so this one. And couldn't find any recurrence. Oh, right, I forgot. There is also the hashtag at the beginning. But still. So convert to, so it's base 16, right? Yes, it's base 16, so what is happening? Okay. What is wrong here? Oh, there are the parentheses, of course. Okay, so 4 and, well, okay, let's do it like this. So trim by these, and let's trim by the hashtag as well, just to get rid of everything that doesn't belong there. And now we can do the last thing. We can do 0 to length minus 1. That makes more sense, and hopefully the result will be much more accurate. So it is not yet. So total boundary points, and I'm not counting the boundary points, right? Or am I? Right, let's see. total boundary points, points inside. Let's check the numbers if they make sense. So the second point should have right. What I didn't fix is this. So we are going down here and we are going to the left, so right, left, and finally up is this. So now maybe we'll see. Oh, bigger number for sure, but maybe we're overflowing somewhere. So let's do the proper thing here and do record point long x long y, just so you have large numbers and we're ready for this. Right, this would be here. So point, hopefully this should be large enough. And yeah, that seems better. Oh, yes, it is. Okay, so that's what we need. So now let's try with the large input. Okay, very large number. But it is correct. So that's it for the day 18. It was a quite intriguing and tricky one. I made one huge stupid mistake, but we have the solution, and it was a purely mathematical one. So nothing really algorithmic this time. It was purely about knowing these formulas and being able to apply them together to get the actual result. So quite different problems, quite a different set of problems today, but it was nice to see, and it kind of changes the pace of the Advent of Code competition. So yeah, it was nice. So I think that's it for today. I will do more videos, hopefully finish this whole event, but make sure to tune into the second video where I will use ChatGPT to see if it's able to solve the same problem as I was solving here. And yeah, I will see you in the next video. Please subscribe to get notified about future videos, and keep coding. Bye bye.